Hello all, this is Anum. In this video, I'm going to explain the formation of a radar data cube for TDMA MIMO. Well, I hope most of you know what TDMA is. So TDMA is basically time division multiple access. In a TDMA based system, only one of the transmit elements transmit at any instant of time, whereas MIMO is multiple input with multiple outputs. In a MIMO system, you have multiple transmit elements and multiple receive elements, and the specific arrangement of these transmit and receive elements forms a virtual array of m into n elements, where m is the number of transmitters and n is the number of receivers. To start off, I'm going to consider a small simulation scenario. Let us assume that we have a TDMA-based monostatic radar with 4 transmit elements and 8 receive elements. Monostatic radar is basically a radar in which both the transmit elements and receive elements are co-located. So in the vicinity of this radar, we have 2 targets, which in the current scenario are 2 cars in white and red colors. So as explained earlier, transmitter 1 will transmit first. This signal will be received by receiver 1 after being reflected off from targets 1 and target 2. After this process, we will now have one row of the radar data cube with time samples along x-axis and number of sweeps along z-axis. Similarly, the signal would now be received by receiver 2, which will form the second row of my radar data cube. The process will continue. It will repeat for all the receive elements to form, let's say, one of the squares of a radar data cube with number of receive elements along y-axis, time samples along x-axis, and number of sweeps along the z-axis. The same thing will again repeat for transmitter number 2, transmitter number 3, and transmitter number 4. The process will increase the number of sweeps along z-axis with each sweep corresponding to a specific transmitter. So after this process, we have a radar data cube which simply started from a single row of time samples. Now let us say we have m number of sweeps. We have a complete radar data cube with time samples along x-axis, number of antenna elements along y-axis, and number of sweeps along the z-axis. Now if we want to find the range versus Doppler plot from this radar data cube, what we do is that at any spatial sample, we perform a 2D FFT across range samples and across the sweeps. For range versus azimuth plot, what we need to do is that at any specific sweep, we can apply the range FFT followed by the beamforming algorithm for angle of arrival. You can also use any other method you want to use to determine the angle of arrival. Finally, for the azimuth versus Doppler plot, we can select any of the time samples and then by FFT across the number of sweeps and beamforming algorithm, we can determine the azimuth versus Doppler plot. However, the important point to mention here is that this radar data cube is not according to the MIMO, as along y-axis we just have 8 rows corresponding to 8 receive elements. Now I'm going to explain how we can process this radar data cube for TDMA MIMO. Let's start with the radar data cube we initially developed. As I explained earlier, all the blue sweeps are due to transmitter 1, yellow sweeps are due to transmitter 2, red sweeps due to transmitter 3, and then green sweeps due to transmitter number 4. So what we are going to do is that we will stack all the different colored sweeps on top of the first sweep corresponding to transmitter number 1. So now, after all the processing and arrangement of the initial radar data cube, we have a TDMA based MIMO radar data cube. Along y-axis, we now have 32 elements corresponding to 4 plus 8 physical elements, where 4 is the number of transmit elements and 8 is the number of receive elements. However, as you can see that number of sweeps are now reduced by number of transmitter times. Therefore, this process reduces Doppler resolution a little bit, but we can improve the angular resolution. I hope I am able to explain the concept of TDMA MIMO. Please let me know if you have any questions in the comment section below. Thank you.